Hi, physics. Mr. Janowski here. This is another homework video. This is homework 3, chapter 4, homework 3, and I'll do problems 3A and B. So what's going on here? So Mr. Walsh's Mustang, Mr. Walsh used to have a Mustang, can go from 0 to 26.8 meters per second in 3.60 seconds. Assuming it accelerates at a constant rate the entire time, A, what is the acceleration? So we will start off, of course, with step, So what are we looking for? What is the acceleration? A is equal to question mark meters per second squared. And then after that, we need to do step 1. We need to make a sketch. So, whoop. All right, that's terrible. That's slightly better. Okay, so there's the ground. Here is going to be a very boxy Mustang. And the wheels should be touching the ground, but forgive me, it's hard to draw on this. So yeah, what's happening at the beginning of this? The car is going 0 at the beginning. So V initial is 0 meters per second. So it's not moving. There's no speed lines. And then the car is going to speed up. And at the end of the problem, the car will be over here. It's definitely moving at the end. So there are speed lines. And we have V final equals 26.8 meters per second. So why in the world did I pick that number? 26.8 meters per second is 60 miles an hour. So that's why I picked that number. When they talk about cars, they often talk about how quickly they can go from 0 to 60 miles per hour. So a sports car can do it fairly quickly. Technically, a Mustang is not a sports car. It's a muscle car, but we'll just go with it. So that's what's going on there. Actually, let me point out one other thing here. So sticking with step 1. So this is a sideways problem, so we'll use x's. So x initial is going to be 0 meters because just always make the first one 0. And x final. So the car has moved some distance. How far has it moved? We don't know how far it's moved. This is actually what we'll be looking for in part B. So question mark meters. Now we will do step 2. So this is a sideways problem, so I'm going to use x's instead of y's. So we have x initial, x final, v initial, v final, a, and t. So we've got to figure these things out. So x initial, yeah, just always make that one 0. And actually, let me point out, a good piece of advice is if you're struggling on your step 2, make sure you're getting your information for step 2 from your step 1. Have a good sketch, have a good clear picture of what's going on, and then draw your information out of that. So we're starting off, x initial is where we're starting off sideways. That's here, and that's 0 meters. X final is where we're ending up sideways. So that's over here. It's not 0. It's definitely, the car's definitely moved, but we don't know what this one is. So this one is a question mark. How fast is the car moving at the beginning? No speed lines. V initial is 0 meters per second. How fast is the car moving at the end? Speed lines. V final is 26.8 meters per second. What is the acceleration? Okay, this is tricky. We're on Earth. However, this car is not in free fall. This is not a Mustang falling off a cliff. So that means A is not G equals minus 9.8 meters per second. How fast does this car accelerate is actually what we're looking for. That's our step, So question mark, meters per second squared. And T, how much time does it take for the car to get from here to here? We do know that number. That number is 3.60 seconds. So we have that. Now, step 3, which thing are we looking for? We're looking for A. We're looking for the acceleration. So A is equal to that. I'll get there. Boop. And now for step 4, we have to pick an equation. So picking an equation, it has to have A in it. So 1 has A in it, 2 has A in it, 3 has A in it, 4 doesn't. So it can't be 4. We also have to avoid the other question mark. The other question mark is x final, which means we have to avoid delta x. So 1 is a delta x, 2 doesn't, 2 will work, and 3 has a delta x, and 4 we already know isn't going to work. So yeah, we get to use the second one, which is good. The second one is the easy one. So we have v final is equal to v initial plus at. Now, pro tip of the day, do we have any useful zeros? We do. V initial is 0 meters per second. So that will just go away, and that leaves us with v final is equal to at. So on to step 5. Whoop, if I can find my cursor. On to step 5. Step 5 is do the math. So when you do the math, what you should do is keep the problem in letters for as long as you can until you have the thing you want by itself on one side. The thing I want is A. So right now, A is on the right side, and it's attached to the T. How do I get the T away from the A? I divide. So if I divide both sides by T, boop, divide by T, and now I'm going to switch left and right. That's going to give me A is equal to V final over T. So this isn't that bad. So I've done it in letters as long as I can. Now I have to go to the numbers. V final is 26.8 meters per second. T is 3.60 seconds. Okay, so ask your calculator what's 26.8 divided by 3.60, and your calculator will tell you that it is 7.44 meters per second squared. And so this is A. Put a box around it. Do step did we solve for the right thing? Did we give it the right units? Yes. A, meters per second squared. We have A, meters per second squared. Now, is this number reasonable? This is a little tricky because we don't often deal with, well, how many meters per second squared is a car accelerating? And the bloody cheetah rule doesn't really work for this either. The only thing we can really compare this to is G, the acceleration due to gravity. And this is in the ballpark of that number. It's a little bit smaller. You kind of have to guess. But yeah, this is a reasonable acceleration for a Mustang, a muscle car. So that's reasonable. You give it a check. Now let's go on to part B. And I should be able to do this whole thing on the same one if I can erase very carefully. So in this problem, part B is exactly the same situation as part A. The car is starting at rest, and it's accelerating constantly until it gets to 26.8 meters per second. So that means I get to keep the same sketch. And I get to keep basically the same variable bank. The only thing, of course, is in part A, we figured out that A was 7.44 meters per second squared. So 7.44 meters per second squared. So now I have that. I guess to be good, I should do step for part B. So part B, step how far does the car go in that time? Far. We're looking for delta x, but really x final. So x final is equal to question mark meters. Okay. So yeah, like I was saying, that was part A's step I'll get rid of that. Bleep. Okay, for part B, yeah, here's our step We're going to use the same sketch, mostly the same variable bank, although of course we now know another piece of information, so we're happy about that. Part 3 is, what thing are we looking for? Basically two-step again. We're looking for x final in units of meters. So we have that. And on to part 4. I'm sorry, on to step 4 for part B. So step 4 is pick an equation. So it has to have an x in it. Okay, so the first one has an x. The second one doesn't have an x. The third one has an x. The fourth one has an x. Okay, so it could be 1, 3, or 4. And the other condition is we have to avoid any question marks, any other question marks. And at this point, there are no other question marks. We know all of the things, um, which means we're free to pick any one of these. So when I did this in the solutions, I went with the fourth equation. So let me write the fourth equation. Delta x. Let me write a little more neatly than that. That wasn't a very good delta. Okay, so delta x is equal to v initial plus v final, all of this over 2, and all of this times t. Okay, pro tip of the day, useful zero. Yeah, again, v initial is 0, so that goes away. So that's going to give us delta x is equal to just v final over 2. Sorry, that's 2 times t. On to step 5. Step 5 is do the math. We're trying to get delta x by itself on one side, and we already have that, which means I don't have to do any algebra to the letters. I can just go right ahead and put in the numbers. So delta x is equal to v final, 26.8 meters per second, divided by 2 and multiplied by the time, which is 3.60 seconds. So if you ask your calculator for that number, 26.8 times 3.60 divided by 2, doesn't matter what order you do it in, as long as you're dividing by 2, it is going to give you 48.2 meters. And this is delta x or x final. I'll call it x final this time. So we put a box around it. Now we do step, did we solve for the right thing? Did we give it the right units? We wanted x final in meters. That's what we got, x final in meters. We got 48.2 meters. So about 50 meters. So about 50 yards, about half of a football field. Try to imagine, a performance car speeding up from 0. It's going to do it pretty quickly. So it does kind of make sense that it could get from 0 to 60 miles per hour in half a football field. So that's a reasonable distance. So we're happy about that. So that's how you do 3A and 3B. Now, a little bit of warning about 4A and 4B. It's the same car. It's a Mustang. Only this time it's going to go from 60 miles per hour, 26.8 meters per second, to a stop in 38.0 meters. So yeah, it's the same car. However, this time we're testing the brakes and not the engine. And the brakes will accelerate the car different than the engine, which means when you're doing part 4, you can't just grab, you're going to need a new sketch, first of all. And A is not going to be the A that we just found. And T is not going to be the same T as in the first one. So, yeah, that's my warning about question 4. So hopefully you found that helpful.